Do you ever work with pneumatic actuators? Our Easy Pneumatics Controller is the easiest way to control air-driven motion I have ever seen. The no-code programming interface is so easy, even I can program it, and that's saying a lot. Create sophisticated motion in minutes, not weeks, with Easy Pneumatics Controller. Learn more at teampipeline.us.
I guess there was a point in time where one of my colleagues was an ex-Green Beret. And in a fit of frustration, I called him up and I said, man, what do you do when you've got someone on your team who's just shooting everything except the target? And his answer was, I'll tell you what you don't do. You don't take the gun away.
Hello and welcome to yet another riveting episode of the Being an Engineer podcast. Today we are thrilled to have Joe Moak on the show. Joe is a veteran guest of the Being an Engineer podcast. If you have not heard his first episode, which was a few years ago now, I highly encourage you to go out and find it. No joke, being completely genuine, Joe is one of my absolute favorite engineers that I have ever met. He's just a wonderful human being, super, super smart. Really, truly knows his stuff more than nearly every engineer I've ever met. He's brilliant, and I am very, very grateful that he has agreed to be on the show again to talk about how to accelerate the speed of engineering. Joe, for those of you who have not heard his first episode, a little bit of background, is a seasoned mechanical engineer and product architect with a deep commitment to creating sustainable, user-centric products. Currently, he serves as a senior product architect at Meta, where he focuses on introducing new technologies and developing product architectures. Joe is also the founder and chief engineer at Maestro PD, a design engineering firm dedicated to helping clients bring high-quality hardware products to market. His extensive experience includes leadership roles at companies like Apple, Sonos, NeuroPace, where he has driven innovation across various product lines. Joe, welcome back, and thank you again so much for being here.
Thank you so much for the very kind and humbling introduction.
All right. So we are privileged today to talk about a topic that I am so interested and passionate about, which is how do we accelerate the speed of engineering? Joe, you've been around this industry for a long time. You have held many different roles, from individual contributor to leadership, to very high level leadership roles. And I am so excited to hear about your insights into these questions. So let's start with, before getting into how do we accelerate the speed of engineering, what are some of the things that slow down the speed of engineering right now? What are the bottlenecks that you have seen?
Yeah. There are three that come up more often than I would like, and sort of like themes throughout my career. One of those things, I'm sure many engineers listening to this podcast are going to be familiar with: changing requirements. You do a bunch of really good work and you engineer a part or a system and you build it, and some stakeholder says, it really needs to weigh a little bit less, or it needs to move a little bit faster. And you think, man, it would have been good to know like 9 months ago when we were actually engineering that system. That happens often. The other really common problem are what I sort of bucketed as development process failures. There's, especially in larger organizations, or sometimes even growing organizations, trying to figure out sort of the level of process that's required to hold a team accountable and to support collaborative process development without creating so much overhead that the process starts detracting from the we'll call it real engineering and design work that needs to get done. And I have tons of examples. And then the last thing that I had sort of or the last thing that came to mind as we were thinking through this is, learning about design issues really late in the development process. And it's tied a little bit to number 1 and 2. But there are always situations where, you think you're at DVT or PVT and you run your test units through the RHEL suite and you find out like, oh yeah, there is this 0.5% failure that's happening. And, there was no other way to learn about that 0.5% failure before we had built, the 1,000 units that it took for that one to fail. But there are other times, we may talk about this later, when you try to rush the process, right? And, you kind of shortchange that testing or whatever evaluation needs to happen. And then you think you're done, but then you realize, no, we're not. We've got bigger problems now. We've got new problems.
2 follow-up questions for you. Going back to the scope changes, do you think that scope changes are just inevitable? There's no way to eliminate their occasional occurrence? Or have you found some ways to mitigate the scope changes up front, different forms of communicating with stakeholders, things like that? And then the second question is kind of just tangential, really, but have you found, you talk about processes and procedures, potentially bogging down a project. Have you ever seen, like, is there, in your experience, a correct or an optimal number of team members, but then beyond that number, the process just gets to be too cumbersome? There's too many tools required to communicate with people and things slow down.
Yeah. Great questions. Your first question, I'll answer that one first. The answer is absolutely yes. There are ways to manage changing requirements, to anticipate and manage changing requirements. As a matter of fact, many of the projects that I've undertaken in my career have some element of kind of figuring out how good a product can be. What kind of performance can we get out of this product? Is it even possible to get, this acoustic performance in this size of an enclosure while also not overheating and not crippling the antennas, for example? Like, these come up all the time. And I may talk about this more later, but the answer is, I don't know that it's complicated, but it's maybe a different way of thinking about the design and development effort. Instead of, committing to a particular, performance target, you sort of set performance goals for each element of product performance that your customers are going to care about. So kind of following that acoustic product, thread, there's something about acoustic performance. Nowadays, there are a lot of speakers, consumer speakers especially, have some kind of wireless connectivity. I don't know if it's portable. There's maybe a battery life trade-off. The reality is that nobody knows exactly the perfect embodiment of like battery size and antenna architecture and thermal capacity. So processes that can justify themselves really support the team in understanding, how to achieve some design targets while not necessarily, compromising some particular element of the design to hit a target. In other words, like, if you over-index on, I don't know, runtime, like, sure, you can make a speaker that doesn't have to be charged but every, 3 weeks, but it's also going to be like very big and heavy and expensive. Right? So yeah, this idea of like iteration on each of the elements of the product and driving each of those elements or subsystems toward product level convergence is the way that I've managed sort of that changing requirements landscape, tactically. And then strategically, I try to be upfront with the stakeholders about the fact that I might not, or this team, my team, any team you hire, or bring on might not actually be able to achieve these performance goals that you have written down or that you have in your mind. They may not be able to repeat exactly what you've built on the lab bench. However, here's the process that we're going to leverage to figure out how close we can get.
Brilliant. How about team sizes? Have you seen, go for it.
The team size thing. I don't have a great answer for that. You need enough people that the work can get done sort of, sensibly and expeditiously, but not so big that you're overburdened by communication overhead. And there are a lot of different ways that you can navigate that problem. You can bring in or bring up communication systems. We can talk about the good and the bad there. You can bring in, more experienced people onto the team to solve problems. Sometimes, one person who in the past has solved that exact problem a time or two is going to be more effective than 3 people who are trying to figure out how to solve that problem. Again, all of these options are heavily constrained by your time, your budget, sort of the resource or talent pool that you have access to. But I'm trying to think of like a rule of thumb of a project of size X, a team of size Y is too big.
Maybe we just, maybe the takeaway here is just that, more people does not always equal more progress. There is such a thing as a team that's too big, and what that exact size is kind of depends on the exact situation. But just be aware that more people is not necessarily going to mean more speed.
100%, especially in hardware. I think there are other disciplines. I'm not a software engineer, but I have a lot of friends that work in software, and they've described sort of the modern software development process enables teams to scale. Like there are particular flavors of software programs that I am told can move more quickly if you slice it up a little more finely and you bring in more engineers to work in parallel. You can do that with hardware. As a matter of fact, I believe we should do that in hardware. I think the sort of the slicing of the efforts is, I don't know, this more heavily constrained, differently constrained.
Even in software, I know very little about software development, so I could be speaking out my side here, but I'm going to guess that it's not a linear relationship. If you double the number of people, you don't double the amount of progress.
I'm sure there's some point of diminishing returns. Yeah, like if you could have every engineer in the world working on your project, it's not going to get done tomorrow.
Yeah. Well, something you said earlier was just a perfect segue into the next thing I'd love to talk about. You talked about if you have one person that has already solved this problem, that individual is probably going to lead to faster outcomes, faster results than 2 or 3 people who are trying to figure out how to solve that problem. Yeah. So, junior engineers especially, but also more senior level engineers, we all have occasions where we don't know how to solve a problem. And there are times when someone else does know how to solve that problem.
Yeah.
How do you balance allowing an engineer to develop that muscle of like figuring out how to figure things out versus just go ask the person who already knows the answer and move on?
What a great question. The first thing that comes to mind when I hear this is, in the past, I've had, either younger engineers, or we'll just call them less experienced engineers that were kind of doing a lot of work, but not really making progress or not really solving problems. And at the time, there was a point in time where one of my colleagues was an ex-Green Beret, and in a fit of frustration, I called him up and I said, "Man, what do you do when you've got someone on your team who's just shooting everything except the target?" And, and his answer was, I'll tell you what you don't do. You don't take the gun away.
Oh, I love that so much. Great. Keep talking. I love this.
And that one really felt like a kick in the shins, because that was almost my first instinct, right? Like I just wanted to eject this person from the team. And I realized, okay, well, there are better ways. And my job as a leader is to, empower the team to do their best work. And so, I took a deep breath and I realized, okay, well, I'm not taking their gun away. I'm not going to take away their bullets, but I definitely need to show them where the target is. And maybe we need to talk about, I don't know, trigger technique. Sorry. Now I'm not a Green Beret sniper, so my language is going to falter here. So it made me realize I actually know how to solve this problem. For a long time, I've had this policy, just a personal policy, that I don't ever touch anyone's computer. And I've worked at companies, where we've been, I don't know, like in bullpens or like open office spaces. And it's really common for engineers especially to share ideas and trade tips. I learned how to do this thing. Let me show you. Or, hey, I've got a problem. Can you show me how to, model this thing in CAD or set up this simulation? And it's really common for, one engineer to walk over to another engineer's desk and the other engineer to step aside and,
sure.
The knowing engineer clicks and points and types, and then it's done. I just tell people, no, I'm not going to touch your computer, but I'm going to show you how I would solve this problem. I'm going to show you, where I would click if I were to do this. And often, even before I do that, I'll ask questions about the problem that they're trying to solve. I don't know. Are you familiar with the XY problem?
No.
I'm going to butcher this because again, it's not top of mind. And I read the story one time, but it's when often inexperienced or less experienced folks will ask a question of experts like, what size screwdriver do I need, or should I be using to, change out the breaker in the breaker box? And then if you ask a bunch of questions, you realize, your power main is down. Like, don't worry about the screwdriver. Like, the screwdriver is inconsequential. Like, you've got a different problem that you need to solve first. So anyway, I try to keep that in the back of my head. I'll ask questions about what are you trying to accomplish here? Like, what's the issue? And then if we do arrive at a point where, some clicking needs to get done, then I'll describe, how I would click. Or if there's like a calculation that needs to be done, or if there's like a problem that needs to be defined, I'll talk through how I would sort of imagine the definition of the problem, how I would go about solving it. But I try to not solve problems for people that have asked me questions, even if they've asked me for the solution. And I give myself, I don't know, maybe a C+ or a B-. I still have this inherent, desire to fix things and solve things and design things that I have to actively tamp down in these situations.
Well, you're a man and an engineer, so you've got like two strengths against you already in that area.
Totally. Yeah. It's a constant struggle.
Yeah. I really like the fact that you mentioned asking questions, because sometimes the problem that is brought to you is not really the problem that we should be focusing on, but that's the way that the engineer contextualizes the problem as opposed to like the bigger picture. And that in itself can be a great way to accelerate the speed of engineering, figuring out what problem are we really trying to solve.
Yeah, absolutely. Absolutely. I can't remember where I heard it, but one of the other ideas that I like to sort of hold in the back of my head is, if I can't solve the problem, can I change the problem? And after I change it, then can I solve it? And there's, if that changed problem still is a valid solution for the product, then fine. If the changed problem doesn't, move the program forward, then the answer is no, you can't change the problem. You have to solve the problem.
Great way to think about it. I remember when I was in college, one of my roommates who was a really bright engineer, still is a very bright engineer. I was stumped on, I don't know, it was a thermo problem or something like that, one of the course classes. And I was like, hey, Mark, how do you solve this? Like, well, what would you do on this problem? And he looked at it and he was like, well, I'm not really sure how to solve it. But here's something that we could try. And I was like, well, that doesn't seem like it's going to lead directly to a solution though. And he says, yeah, maybe not, but it's something we can try, and we don't know what else to do. So let's just try this thing. And lo and behold, we tried that thing and maybe it didn't directly work, but then we realized, oh, we could also try this thing. And we got there eventually, right? So sometimes when you don't know how to solve the problem and you do realize there are a couple of things you could do, even though those things don't necessarily seem like they would be a direct avenue towards solving the problem, but they're tangentially related. Just do those things. And oftentimes they lead to other things that you can't see from point A, but once you get to C or D, oh yeah, there's F, and I see F leads to Z, and now we're done.
Yeah. Yeah, absolutely. What a great story. What Mark, had done there is he helped you guys understand the sort of the bounds or the extent of the design space.
Yes.
That's how I like to think of it. While it may at first blush seem like wasted effort to try something when you don't know if it's actually going to solve the problem or not, you are inherently learning something about the problem.
Yes.
The worst case is you learn that that's not how to solve the problem and there's no solution there. Great. You know that you need to try something else. And in really great cases, you learn, again, where the bounds of that design space are.
Yeah, absolutely.
Maybe we'll talk more about that.
Probing
later,
the limits of that design space.
That's right.
What are a couple of tools that you have seen used effectively to fail fast and inexpensively?
I have some pretty strong opinions about this. And a lot of it is built on what I learned at Apple, good and bad, that I've then carried forward and kind of tried out in different organizations that didn't have, we'll just call it all of the resources that Apple had. And, I mentioned earlier, lean product and process development. They're a pretty good set of, principles and philosophies and tools. And I'm going to attempt to summarize what I think the most important of them are, like the ideas that I leverage most of the time. In that lean product and process development parlance, you'll hear it referred to as, concurrent set-based engineering. It's also, referred to as parallel path development. And the way that I sort of conceptualize these, product design problems is really in terms of system design, and folks that have studied system design are maybe going to chuckle at how I butcher this. But fundamentally, what I like to do is, take the product proposition and kind of decompose that product into constituent parts that can be sensibly, attacked by subject matter experts. Right? Going back to the speaker, cause it's relatable. There's an RF system. So you need to enable an RF engineer to do some RF work. There's, maybe a thermal system you can piece out. So a thermal engineer can do some of their work. There's obviously the mechanical design of the product design that, sort of the shape and materials of the parts and the assembly process. So you end up, in early phases when you do this right, you've got, half a dozen different work tracks, and you can deploy, a person or a team of experts on each of those little subsystems. And, when you're doing it well, sort of everyone is informed, ideally embracing the product proposition and the customer value behind the product. It needs to be small, it needs to be light, it needs to be portable, it needs to be high fidelity, like whatever the hallmarks of the product are. And they each drive their piece toward the highest level of performance they can achieve within the product embodiment. I feel like I've done a lot of talking there. I have more to ramble about, but I'm going to pause there for a reaction. Am I making any sense?
Yes, you're absolutely making sense. The idea of parallel path development, I think, is highly productive and efficient. My follow-up to that is going to be, what happens when you don't have enough people to split off into multiple paths? Your pool of engineering resources is limited. Any thoughts about, other or different tools or techniques for failing fast, failing inexpensively in a smaller development team?
Yeah. Smaller development team, I think the answer is the same for a small development team, or I don't know, maybe a compressed schedule. You just have to start making risk calls, right?
Okay.
You have to you either have to convince yourself that if we miss this particular element of performance, customers are going to be okay with it. Or you extend the schedule, or you hire the people, or you don't market the product, using that feature as a hallmark.
Yeah.
Yeah.
There are only so many knobs to turn, right? I mean, we're not trying to create magic here. In fact, sometimes I wonder if there really is no way to necessarily speed up a development project. All we can do is eliminate the unforced errors that could occur, should we not make the right choices.
That's a nice way of thinking about it. One of the tools that we have at our disposal when we've sort of decomposed the product or the system and we're working the subsystems independently is that we can build, I'm going to call them relatively low fidelity prototypes really quickly to learn about product performance really quickly. And this was one of the struggles that I've seen. Oh gosh, I guess it's several companies, but I've got some, pretty specific stories hanging out in my mind. I'll tell this story. We were at Sonos and we were developing the Playbase, and there's always tension between acoustic performance, RF performance, and thermal performance. We didn't want to put a blower into the product. We were trying to passively cool the whole thing. And the question is, like, how big does the heat sink need to be? And if you ask the thermal engineer, it needs to be all the size. It needs to be the whole product, right? We want to spread heat everywhere. Of course, materials that are great thermal conductors tend to be radio opaque. And so the RF engineer says, no, like, keep the metal away from my antennas. And by the way, the elements in an acoustic product that make sound are also typically radio opaque, right? They're, ferrite and metal and, copper coils. So the RF system ends up being really sensitive to all of this metal in the box. And so, what I did is I built a prototype for the RF engineer out of 3D printed parts and laser cut parts. And then I covered the 3D prints and the laser cut parts with copper tape or aluminum tape to represent where metal was likely to be in the box. And then, I was also building acoustic prototypes for the acoustical engineer to explore different driver configurations. And there was a moment in time where, right in the middle of development, the acoustical engineer identified a significant performance increase by switching the location of the woofer driver and the port inside of the box, which was a giant movement of metal. And, previously this would have been, quite a tear-up and quite a delay. But within not minutes, it was probably an hour and a half, I went over to the RF engineer's desk and we talked about the switch. And he's like, oh man, I'm going to have to reevaluate all of my antennas. Of course, yes, it's a bummer. You're going to have to do some work. By the way, I'm just going to switch these parts right here. And now you can go do your work and do your redesign. And it was,
that's
hours
wonderful.
And not weeks. So, I think the big idea there is, lean product and process development parlance, they'd call this, I don't know, rapid learning cycles, something like that. And, evaluation of configurations. And the metric for success there is not, how fast did we build one thing? It's how many different configurations have we evaluated in this period of time. And as you evaluate more and more different configurations, we can talk about what configurations mean, but the more you understand about, how the size of the heat spreader extends to the left or to the right, and what effect that has on the antennas, the better you understand your design space and the more quickly you're going to be able to converge on a plan of record that you'll then go execute. And then by the time you're designing all of the details into your mechanical parts to accommodate injection molding and metal stamping and forming and casting and all this high volume manufacturing processes, you've got really high confidence that when those parts come together, you're not going to find a thermal error or you're not going to find an RF error.
There were two things that I picked up on there. Correct me if I'm wrong here, but one of them was maximizing shots on goal, right?
Yep.
And then the other one was you actually built something, probably several things, but you prototyped something.
Lots.
You put some, aluminum tape on it. You actually got the hardware quickly.
Yeah.
Which probably enabled the maximization of shots on goal.
Yeah, that's right. That's right. One of the questions I'm always asking myself, I'm always asking the team is, what are the biggest risks? Sometimes that's for us to answer. Sometimes that, executive leadership is answering that question. But when we know what the risks are, we have some belief about the high risks. The question is, what can we build right now to understand that risk level? Sometimes there are team members that, I don't know, they think that there's a risk that may or may not be real. Sometimes we disagree. What can we build right now to understand the level of that risk?
I love it. Yep. We talked about processes a little bit.
Yep.
Do you have any checklists that you use to ensure the right things are being done at the right times and thereby accelerate the speed of engineering?
Absolutely. I'm going to start with the things that are not checklists necessarily, but I think really important to support the process, before you even get to a checklist. It's sort of before you know whether or not you can check a box, you need to know how good or bad your item can be, right? So, fundamentally, all you need to run a hardware program is, a master CAD model, a schedule, a bill of materials, and a master issues list. Those are the four things that you need. And that helps you understand the product. If you're lucky, you'll have some product requirements or some product goals. Again, when you're innovating, you're developing the product requirements as you go along. You're understanding how great your product can perform. Assuming you've got all that in place, you've done your homework, the team is set up for success. Absolutely, drawing release checklist is super important to me. I also I call it a DFM release checklist. It's like, I've got a pretty strong opinion that before we send specs to suppliers, certainly suppliers that we are meeting for the first time or working with for the first time, we need to make sure that we have our house in order. Our CAD needs to be tight. Our drawings need to be tight. We need to demonstrate to this supplier that we not only understand our design, but we're able to communicate really well through engineering specifications. Depending on who you're dealing with on the other end, they may see a poorly formed spec or poorly executed CAD as an opportunity for them to cut corners in their process. So DFM release is incredibly important to me. I also run what I call an okay to tool release. So after we've gone through a DFM cycle, even after we believe we've reconciled all of the part geometries with all of the design for manufacturer feedback, we got drafts and rounds and bend radii, bend reliefs, and we've been through mold flow. We know where we're going to inject the parts, where the gate locations are. We've gone through ejector pins, everything. I run the team through another checklist to say, yeah, for every single part, yes, we actually have done all of the work, and no, we haven't missed anything. And, depending on the, it usually comes down to how expensive the tools are, like how big of an investment are we making in tooling. I can often, get support to have, a second review done. So every part, is reviewed by the engineer that owns that part, and also a buddy who is completely unfamiliar with that part.
Terrific. Which might sound like kind of an extensive, maybe even too much work to put into this, but especially if you're doing high volume manufacturing, that extra time you put in now is going to save mountains of cash and time in the future.
Yeah. Yeah, that 100%. We, I'm trying to think of an example. Yeah, at Sonos Playbase, we probably had, 24 tooled parts in that neighborhood, 36 tooled parts. And, we went through the reviews in, a week or less, which may sound like a long time, but if you've ever dealt with a line down and had to, take down a tool and modify it and then bring it back up and make parts, that's, that can be several months.
Yeah.
So it becomes, it's not justifying a review cycle is not the hardest thing I've done.
Absolutely.
And then there's an okay to build. I got an okay to build checklist. Even after we've built parts, I want to make sure that the parts are, not going to create any issues if we, build 200 units with them. So I got a checklist for that. And then a big one, which is real fun, is, the PCBA okay to fab checklist. And that one is incredibly important and, very cross-functional. I think we may talk about cross-functional interactions later. But that okay to fab checklist is, another sort of, it appears to be time consuming up front. Also way less time than dealing with the litany of issues that arise when you think you're going to move fast and bypass the check.
All right. Those are wonderful checklists. Thank you for going through that. The next thing I'd love to talk about is safety in your team, not physical safety, but psychological safety. And in my experiences, this has been a big one where, team members, if they don't feel psychologically safe to share their thoughts, to tell you what they're really truly thinking, that can be a source of giant obstacles. And you might not even realize the obstacle ever in the project. You'll just encounter problems that you need to overcome when, if team members had felt safe enough to express concerns, that those problems never would have materialized in the first place. So do you have any stories or experiences that you can share where, you or other leadership helped engineers to feel safe enough to express concerns, bring up, whatever points that they needed to bring up?
Yeah, man, this is something I take really seriously. I've seen many really good ideas get shot down for really bad reasons. And I put a ton of effort into building certainly my own companies and building my teams so that, we create a safe space for ideas. Many of our projects start with brainstorming sessions of some kind. Whether it's product definition brainstorms or brainstorms around solving particular, design or engineering problems. Certainly with new teams, and I'll even do this on teams that, have been working together for a while. I'll put up the brainstorm rules up on the board, right? The parameters for success or the metrics for success are the number of ideas generated, not whether or not we can patent any of these things. Quantity,
not quality.
Absolutely. I will myself throw out bad ideas just to demonstrate like it's going to be fine.
I love it.
It's been really, I think one of the challenges, that I've had to deal with myself personally is I never aspired to be a leader, and I often don't want to be the senior person in the room. And I have to sometimes remind myself that whether I like it or not, I am the oldest guy in the room. I am the most experienced guy in the room. I might be the guy paying the bill for the meeting. And it just puts me in this position that I don't want to be in, where I have this, this authority that I don't even want. And so, I guess the other thing is I get really excited about projects. I get really passionate and really loud. I'm often the first person standing up there at the whiteboard. And so I find myself like handing the whiteboard pen to people, asking people to like go up to the board and write down their idea. So I've taken facilitation a little more seriously, and I've tried to sort of, model the behavior that I'd like to see. Again, by like throwing out the bad ideas. Another thing I've done is, I've given people kudos of different types if they find something wrong with my work or my idea. It's like one of the ways that I've sort of, tried to inject some action into a team that might otherwise be tentative is I'll say, okay, here's the plan. This is what I think we should do. Tell me why it won't work. And if you can tell me why it won't work, I'll buy you lunch. I'll give you a high five. I don't give high fives, but I'll give you a high five or something. There's another idea or another anecdote. And then the last thing that comes to mind around, sort of creating a safe space is certainly where I'm concerned, where my behavior is concerned is I'll just, recognize that when my involvement in a conversation is not going to be conducive to progress. Like there are situations, whether I like it or not, where me being in the room is gonna create some vibe that's not gonna be the best for the team or for the product, despite my best efforts to make it okay. And, I don't know, maybe I'll give myself a D+ for identifying all of those situations. But I'll give myself an A+ for reacting when it's brought to my attention.
Nice. Those are terrific. One I thought of as you were speaking, there's a company called Menlo Innovations. They're a software development company. We've had their CEO, Rich. Do you know Menlo Innovations?
Yeah, I've heard of them. Yeah.
Okay. Yeah. They're a really cool company. Their CEO, Rich, has been on our podcast. I've visited with him, and he has a great book. Chief Joy Officer is,
okay.
Book. Yeah.
That's where, that sounds familiar.
Yeah. So, we interviewed their project leaders once, their project managers. And, every now and then, an engineer is going to have to approach his or her project manager with some bad news, right? We're over budget, we're behind schedule, whatever it is. Yeah. And they have this rule at Menlo that when bad news is brought to the project manager's response is thank you. And that's for then maybe there's some follow-up conversations later, but the first words out of that project manager's mouth are thank you. And it has to be genuine, right? We need to, recognize and appreciate getting bad news so that people feel safe enough giving us bad news.
That's right.
If the reaction is, what do you mean you're behind schedule? Tell me how did this happen? Who's responsible? Yeah. Right. That guy's never going to come to you again with bad news.
That's right.
They're going to cover it up, hide it, and you're not going to know about it until it's too late.
That's right. That's right. And there's, I feel like when you follow some of the principles that we've been talking about, you kind of everyone knows that the bad news is coming, right? Like you end up with these teams that sort of understand the cadence, right? I need to build the prototype for this other team. The testing that they're going to do, it may be good or it may be bad. And, when you've got typically we've got like, at least a weekly cross-functional team meeting where we're all sort of talking about the risks that we see from our individual perspectives. You can minimize surprises. And I find that's, can't solve the problem, change the problem. So if you don't like getting bad news, just like, stay in the loop, or keep people in the loop. Yeah. But that's a really good one. I try to, myself to not react super negatively.
Definitely.
When things don't work. It's like, oh, that sucks. How do you think we're going to fix it?
Yep.
Love it.
I remember one time I was managing a project. I'm the owner of the company, right? And I was managing a project, and I grossly misquoted this project, and we ended up losing a lot of money on it. And I felt so bad. And once I realized how bad it was, I had to let our director of engineering know. He wasn't managing the project. He wasn't really involved with it, but I just felt our responsibility to be like, hey, director of engineering, I screwed the pooch here, and this is what's going on. I just want you to be aware of it. And I was really nervous to tell him about this, even though I own the business. Like, why should I be nervous, right? I'm the one who ultimately buck stops here. Anyway, I was nervous, mentioning it to him. Anyway, so here's what's going on. We're going to just blow the budget big time. I just wanted you to know. And he just said, well, sometimes things go wrong like that, or this happens sometimes. And he was just so like understanding about it. He's, he is my senior for sure. He's been around this industry a long time. He's been there and done that. And I appreciated that reaction so much. It meant a lot to me, and it made me feel so much more comfortable. Should I have to approach him about a problem like that in the future?
Oh yeah.
I'm just much more likely to do so now, as opposed to if he'd been like, what? You've been doing this for a long time. You should have known better.
Yeah. How could you?
How could you? Right. Yeah. So that was kind of a cool experience for me. Let's see here. How about any new technologies or tools that maybe you've introduced to your team that have significantly speeded up or sped up development?
It's not really a new technology or a new tool, but I have several stories about, how I've used, or brought in NX to accelerate, programs.
Really?
And it seems silly. But man, God, what a can of worms, CAD execution and CAD best practices. But I'll give you my two anecdotes. The first one was I had hired, a really good, really seasoned engineer to help me on this project for Atari. And, we brought in this really fantastic industrial designer who had put together this incredible proposition. And our job was to deliver camera ready, we'll call it semi-functional cosmetic models for marketing. And the design proposition were these, this layered stack. So there were about 7 layers up front that were the same. And then there were about, 5 or 7 toward the back. They were all slightly different shape. There was like a kind of a stair step taper. And, we needed to create vents. So creating the layers themselves, not that tricky. They kind of nested together, but the features to create the vents, ended up being like these cuts, that kind of went around the perimeter, and you could only see them from the backside from a really steep angle. It was like very clever on the part of the industrial designer. But the CAD execution was a little bit tricky. And I remember he called me up it was like 9 p.m. He's like, man, I've been working on this for like an hour and I've got 1 layer done. And I've got, these 7 for the back. Like, I'm not going to have this done tonight. Like, we're certainly not sending off this package to the model maker tonight. Do you want me to keep going? And I was like, thanks for telling me, by the way. Back to bad news. I was like, absolutely. Thank you for telling me. If you don't mind, give me about an hour. And I'm going to see what I can do. Maybe I got something. And it was about an hour and 15 minutes later. I had everything modeled. I had all 7 layers modeled, done, step file exported, and he was ready to build out the documentation for the cosmetic build. And I can talk all day about exactly how I did that, but the answer is there's I have not seen another CAD tool that would enable me to do what I had done on that particular project.
Interesting. Let's not go into like too deep of detail, but if you could touch maybe just a little bit on some of that detail, because I've never used NX. I've been a SolidWorks user forever. Yeah. I used Pro-E when I first started, but those are the only two programs. Well, I've done some Onshape lately, I guess. Anyway, total novice when it comes to NX. Yeah. What's the environment like? How is it different from, let's say, SolidWorks?
Yeah, sure. By the way, by way of background, I've used, I can say with all honesty, I've designed, engineered, and built parts using, CATIA, got Solid Designer, ME30, ME10, AutoCAD, Pro-E, Wildfire,
wow.
SolidWorks, Fusion 360, and Onshape.
Jeez.
I've used all of them to some, some more than others, obviously. Yeah. The thing that's different about NX is, I'm going to call it hybrid modeling. So you have a lot of control over where you build sort of interdependencies and parameterization. So you've got as much model history as you want.
Okay.
And you can throw away history when it starts to hold you back. Like you can break interdependencies in the model tree really easily. And that's effectively what I did is I just built a bunch of solid bodies that acted as cutters. And it was like mostly the same everywhere. It was like, I had to get around a corner. There was a flat spot and then there was a transition into a corner. And so I just kind of had like 3 cutters that I would swizzle into place and quickly modify as I needed to.
That's a fantastic story. Just everything about that works together. One of the elements I really appreciate about that is this engineer who you had hired, but ostensibly, well, not ostensibly, you said he is a very experienced design engineer. And so this isn't some junior engineer that's trying to prove himself. He ran into a problem, and instead of just banging his head against it for hours and hours and hours, he called you up and said, "Hey, Joe, this is where I am. Maybe you have some ideas, maybe you don't, but where do you want to go from here?" That's a fantastic way to save time, right?
Totally. Yeah. And back to maybe back to the discussion we had about helping junior engineers. If you're a junior engineer listening to this conversation, maybe we don't say this often enough. Like one of the behaviors of more seasoned engineers is, we'll ask questions, we'll raise flags more. Like I certainly do that more often than I did when I was a younger engineer. I felt like, my job is to figure it out. I got to do it.
Yeah.
When really, kinda.
Yeah. I love it. And you made it safe enough. Whatever relationship that you had in place, he already felt safe enough to approach you and say, "Hey, Joe, I'm not sure what to do next year." That's just wonderful. I love it. Okay. Are there any like unconventional approaches that you've taken to expedite the engineering process? Any stories or experiences that come to mind where you applied some kind of crazy tactic or something? I mean, maybe the NX story could be one of those, actually, come to think of it.
Yeah. This is more tactical and it is related to NX. We did this project for this company called Human that made these over the ear headphones with no headband. And there was one flat surface on the whole product and it was neither plumb, level, nor square. It was off in space. The rest of the surfaces were all swoopy. And we had a team that was, the client required us to use and deliver SolidWorks files. And there were moments where, the engineers would come up to me and they're like, "All right, man, here's what needs to be done. And here are all of the things that I've already tried. And I don't know what else to try. Like I literally I can't build this geometry." And we just got really good at, they would end up just saying, "And I put a Parasolid in the export folder." And then I would open the Parasolid. I would build whatever needed to get built. And then I would export a Parasolid, usually with 2 bodies. And everyone knew you You do a Boolean subtract with the red body, and you do a Boolean unite with the blue body. And they got really good at like rolling the model tree back to the right location and importing my bodies and doing the Booleans and then rolling the model tree back down. So that was a little bit, I think, unconventional. Dirty trick I learned at a previous company when dealing with a lot of CAD coming from all over the world, shall we say. But that's tactical. I think that one of the things I've realized recently that I've been doing this over the past, I don't know, probably decade. And again, I'm going to leverage a domain that I respect but have no experience in. I'm pretty sure it's a Navy SEAL sniper adage that slow is smooth and smooth is fast. And the way that I summarize that often for my teams is I say something like, we move at the speed of excellence. And it's really uncomfortable for we'll call them process managers or even leaders who are really process driven or schedule driven. And it takes, I don't know, I feel like sometimes I'm sticking my neck out a bit when I'm saying, no, I'm not actually going to hit this schedule that you've proposed. Like, we're not going to be ready on that day. We're going to be ready on this day. And I feel like that idea and sort of holding that ground for the team has prevented multiple build cycles. And we may talk more about this later, but I've just seen so many teams rush designs and rush deliveries. And then, God, especially with hardware, you put the pieces together and you're like, oh man, there are all of these little things all these little compromises that we made. And now this thing that we built sucks. Like, we were hoping to run it through rel testing, but they're falling apart during shipping. Like, we can't even put them through rel. And like, congratulations, you just signed up for another 12-week build cycle.
Here at Pipeline, we have, I guess you could call it a management philosophy. It's not really a management philosophy. We'll just leave it at a philosophy that we have these governing principles and supporting behaviors. And I think all too often we get lost in these supporting behaviors. I'll give you a quick example just to build some context around this idea. There was a time when a question was raised about whether or not people could bring drinks into our warehouse. And we're building machines out there and things like that. And your typical corporate response is, no, of course you can't bring drinks into the warehouse. There's like expensive equipment and machinery. And what happens if it gets spilled and something could damage the machine, or maybe it's harmful for the humans, right?
Sure.
And to me, it just didn't feel like, it felt like a corporate policy, and that's not really what it's like here at Pipeline. And so we actually had like extensive meetings to talk about this. And in hindsight, it wasn't really talking about drinks in the warehouse. It was talking about, how do we make decisions at Pipeline? How do we govern ourselves at Pipeline? And what we came up with was this idea of supporting behaviors and governing principles. And so we have some governing principles in the warehouse now. And these principles are things like, keep the equipment safe. Don't harm the humans. Keep things clean so we can be proud bringing customers through on a tour. And, things aren't going to look gross and dirty, right? These are the things that we actually care about. And then, legitimately, I understand there are a lot of people out there who want more than just the governing principles. They want some tactical things to do.
Sure.
So we have supporting behaviors, right? Here's some tactical things that you can do or not do in service of the governing principles. What I really love about this system that we came up with is we empower team members to, at their own discretion, circumvent these supporting behaviors as long as they're meeting the governing principles, because the governing principles are really what we care about in the end, So going back to what you were saying, it's sometimes you have to step in and say, we're not going to meet this deadline. At the end of the day, do we really care about meeting a deadline? No, we don't. We care about delivering a product that is profitable and people love to use. That's what we care about. So you as the leader come in and say, look, if this is really our governing principle, deliver a product people love to use and is profitable, we should not try to hit this deadline because it's going to mess us up. We need to extend that deadline out. Or your CAD example where you're taking Boolean shapes into SolidWorks from NX, right? I mean, generally, like having dumb solids in your model is kind of frowned upon. I think most design engineers would agree with that, but the governing principle is not don't have dumb solids in your CAD model. It's have a CAD model that is an effective communication tool for manufacturing. And if that includes a dumb solid, great. Use a dumb solid.
Yeah. I mean, you want your CAD model to be robust, not fragile. You want it to be maintainable, and it absolutely must communicate design intent. And there are many ways to communicate design intent in a 3D model other than a history-based model tree. But whatever, CAD execution aside, what a brilliant story about principles and behaviors. Incredibly enabling for the team.
Thank you. I think so. I like to think so. All right. Let's see. We're just about at time.
Yeah, we'll wrap it up. If we need to reconnect and answer more questions, we can do that.
I could go for a round 2 perhaps with you. I've got other questions, but
great.
Thank you so much, Joe.
Great talking with you as always, Aaron.
Okay. Take care.
Bye-bye.
I'm Aaron Moncur, founder of Pipeline Design and Engineering. If you liked what you heard today, please share the episode. To learn how your team can leverage our team's expertise developing advanced manufacturing processes, automated machines, and custom fixtures, complemented with product design and R&D services, visit us at teampipeline.us. To join a vibrant community of engineers online, visit thewave.engineer. Thank you for listening.